Our lesson 4. This is our final lesson on science. It's on trigonometric ratios and expressions. It's all about sinusoidal functions, and so this would take a few days, and so we'll do this in parts. The first thing we want to look at is this animation from Desmos, and so we've got this we call a unit circle, and so we can see this is actually going really fast. Just to slow it down, you can see what's happening here, and so in class we would probably do this one at a time, but um, not have all three functions going at once. But this is the unit circle, and so if we can make it look a little bit more circular if you have a better scale. But basically, and these negative numbers don't really mean anything. It's just the line going around the circle, and so as the line goes around the circle, you can see what's happening. And so remember, this is our circle from before. And so as we go through the angles from 0 to 360, and you can keep going up more and more, but it stops and restarts around just after, we'll see, 720. So for two circles, and then it just keeps restarting. So what do you notice about what's happening here? Like, where are these functions coming from? So there's three of them. There's a red function, an orange function, and a green function. And you notice that, like, in terms of the y value, so that you can see a little triangle that's been created, and that's our same triangle that gets created in the circle with different angles, and that's what gives you the ratios: sine, cosine, tan, SOHCAHTOA. And so what these three are, you can guess, are sine, cosine, tan. The red one is the heights. So which value was the height? The opposite side. Which ratio? So this is actually the sine wave, the red one. The orange one is actually the x distances. We can create the x distances. If we click off one of these here, you can see the orange one there is the x distances. And so as the x distance changes, you can see it going to 0, to -1, to 0, to 1. But that's what the orange guy is doing, is the x distances. And the tan, which is opposite over adjacent, you can think of it as opposite over adjacent, so up and over, rise over run. So the tan is actually the slope, opposite over adjacent. So you can see this blue line here, what's happening to the slope every time. So the slope's negative, it's positive here, then it's downhill, it's uphill, it's downhill, it's uphill, it's downhill. So that's why it's going from negative to positive. So this is actually a really neat animation to look at all of the different ratios, sine, cosine, tan, and as they relate to the circle. So these are going to be our functions that we're going to study. In this course in grade 11 university, we don't actually really look too much at the tan, but the tan, like seeing what it looks like, it does help, seeing where we're undefined at 90 and 270 degrees. That's why we're having these asymptotes. But we're just not going to transform them. Okay, so back to the lesson. The goal is to connect sine cosine curves, so the sine cosine functions, to the trig ratios between 0 and 360, sketching graphs using transformations, creating the model, and then using sinusoidal situations. And so we start with the sine function. You can create a table of values, and so these are going to be the heights at different degrees. And so at 0 degrees, what's the height? At 30 degrees, what's the height? 45 degrees, what's the height? 90 degrees, what's the height? And so the height would be 1 at 90. And so we can see the height as we go around the circle. We board at 0 degrees, and the height goes to 1, back down to 0, to -1, and back up to 0. And this is the sine wave. This is the sine function. Looking at this function helps you understand things like related acute angles, why 60 and 120 are kind of like each other, why 30 and 150 are kind of like each other for sine. They have the same height. They also are both positive. Why 210 and 330 are kind of like each other. It also shows you the quadrants, so where is sine positive, when y is positive, when the heights are positive. Where is cosine negative between 180 and 360. And so it really kind of connects with everything we talked about in learning goal 2. Some properties, the period is 360 degrees. It's a full cycle. That's the length of the cycle. The amplitude's 1. The max point's 1. Min is -1. Domain is all real numbers. Keep going forever. And the range is between -1 and 1. And so when we do the transformations, that's helpful to know how that range is changing, just so that you stay inside the lines as well. And the zeros are when all the heights are 0. So at 0, 180, and 360. The cosine function, you can think about the x distances around the circle. So what is, at 0 degrees, what's the x distance as the circle rotates around? So the x distance will be 1 at 0, and then it goes to 0 at 90, and then goes to -1 at 180. The circle just goes around and around. 270, it's at 0 again, the x distance, and 360, the x distance, is at 1 again. And it goes on forever. And again, you can see related acute angles. You can see quadrants. Y cos is positive, 0 to 90, 270 to 360 when x is positive. X is negative between 90 and 270 where the horizontal distance is negative. Period, amplitude, all this stuff doesn't change. We have the exact same shape. There's only a slight difference here with where we're starting, but we're still taking the same shape. You can imagine going back to this circle and turning your head sideways, turning your head sideways looking at the circle. The x distances really just become the heights, and so, but nothing changes in terms of like the shape. You can see that red and orange line, they're kind of the same. And if you fill out the unit circle like we've done before, you see that these values actually just keep repeating themselves. So nothing changes. It's really the zeros that change. Zeros now are when the x value is 0, so they're at 90 and 270. And the last one's tan. So where's the slope? So you can see the slope is 0 at 0, at 180 and 360. The slope is positive between 0 and 90. It's actually 1 at 45 degrees. It's -1 at 135 degrees. It's +1 again at 225 degrees, -1 at 315 degrees. So these are the slopes changing, and they're undefined at 90 and 270. So the period is 180. Amplitude's a sinusoidal thing. This is not sinusoidal, so we wouldn't kind of call it an amplitude. The max is infinity, and the min is -infinity. Domain exists everywhere except on those asymptotes, so 90, 270. In advanced functions, you have another way of saying that, so we'd say like 90 plus 180k, where k is an element of the integers. The range goes on forever. It could be anything. Asymptotes and zeros are similar to the sine function, cosine function, because remember that tan is sine over cos as well. It's opposite over adjacent, rise over run. But wherever cos is 0, then tan's got to be undefined. So some notes, a periodic function. So in class we've already kind of talked about these definitions. A periodic function, something that repeats itself. The cycle is the smallest complete repeating pattern of the graph. Length of one cycle is the period. We're studying sinusoidal, and that's a periodic function, but it's like repeats itself smoothly in a wave type pattern. The axis is the average of the max and the min. So these are concepts we've already kind of talked about. And the amplitude is the height above or below the axis. So if you see something like this, this is not far away from the circle that we had, a Ferris wheel boarding the ground. We can see the graph shows one cycle. The period is 360. The axis of the curve is 11 because the average of the lowest and the highest points is 11. The amplitude is going to be 10 because 10 above the curve and 10 below. For each of these, you can look at them. The period in the first one is 180, because the distance from here to here, which are really the only 2 points I can see clearly, is 180. The axis, which is the average of 19 and 3, is 11, and the amplitude is 8 because it goes 8 above and 8 below the line. The period of the next one's 720. The axis is -5. That's the middle line. And we do that from doing the average, 3 and -13. And the amplitude's 8 because you go 8 above the -5. And the last one, the period is 90. So it starts here and then it hits there again at about 90 degrees. That's not perfect. But just for the sake of this question, we'll say that that's 90. And so it probably is, like, if you look from here to here, you've got a 90-degree period. The axis is a little bit clearer. It's y equals 3. It's the middle line, and the amplitude's a half. Okay? And so we can actually see these are actually your sine cosine functions. And so we're going to look at how to actually